Moving right along today with simplifying radicals. Last lesson was simplifying radicals number 1. We just did numbers. Today, this is the second lesson over this, and we're going to be talking about variables. So now we're going to have radical expressions. We got the square root there, and we've got x, y, m. We got letters underneath. Now, recall from last lesson that to simplify a radical, we looked for pairs. We made factor trees, and for every pair, we started pulling stuff out front, and that simplified the radical. We're going to do the exact same thing today, thinking pairs, except we're going to be looking at variables, but it's the exact same concept. So check it out on the first few examples here, and this is what we're doing today, so we're jumping right in. But I want to point out something right away, that this symbol is called a radical. It's also called a square root. The reason it's called a square root is because there's a little 2 that sits out there. When we don't write it, we assume it's just a square root. Realize that in Algebra 2, you'll do cubed root, 4th root, 5th root, and they'll actually write that number out there in those cases. But if there is not a number, we assume that it's a square root. Okay, that's going to be important for today. Now, the concept, like I said, is the exact same as last time. So think about underneath. Y to the 4th is just y times y times y times y. There's 4 y's. You look for pairs. Since this is a square root, for every pair, it gets simplified. If it was a cube root, for every pair of 3, I guess it's not a pair if it's 3, but for every group of 3, it would get simplified. We keep it simple though in Algebra 1, we just do square roots. So again, I'm looking for pairs. I see a pair there and a pair there. So let's simplify like we did last time. For this pair of y's, 1 would come out front, and I'd cross them off. For this pair of y's, 1 would come out front, and I'd cross that off. Last time we learned that if 2 things come out front together, they get multiplied. If nothing is left underneath, like there's no leftovers, I don't even have to write the radical. And I know that y times y is just y squared. So that would be my answer when I simplify this radical. If I do the same thing for b, again, we haven't really talked about it yet, but there's a little 2 that sits out front there. If I want to simplify radical x to the 6th, I could write it out, x. X to the 6th is just x times itself 6 times. So when I go to simplify this, I look for pairs, and I've got 3 of them. So for this pair, 1 comes out, for that pair, 1 comes out, and for that pair, 1 comes out. There are no leftovers, so I don't even write the radical. X times x times x is just x cubed. Okay, obviously when I look at example C, I don't want to write y out 150 times. So here's where there's a pattern going on that we want to take note of, so that way we do not have to write it out every time. On A, I got y squared. On B, I got x cubed. Here's where the 2 helps us. To figure out how many pairs are going on, you just have to think, how many times does 2 go into 6? 3. How many times does 2 go into 4? 2. So on this one, how many times does 2 go into 150? Really, guys, you're just doing the exponent underneath divided by 2. Okay, well, 150 divided by 2 is 75. So if I were to write out all the y's, there's 75 pairs with none left over. So that's my answer, y to the 75th. Okay, now notice that in these first 3 examples, all of the exponents underneath the radical were even numbers, meaning 2 divided in perfectly. No decimals, nothing left over. When this is the case, there are no variables left underneath the radical, which means you don't even have to write the radical in your answer. Well, it's not always the case, though, that happens. Sometimes the exponent's going to be odd. Okay, so check it out. For A, if I thought the same kind of thing I did on A, B, and C up here, m to the fifth is m times itself 5 times. So if I wanted to rewrite this, I'd look for pairs, and I see one pair of m's there, so one comes out. One pair of m's there, another one comes out. This guy, though, he does not have a pair. So just like with numbers last time, it has to stay underneath if it doesn't have a pair. M times n on the outside would be m squared, and then it'd be radical m. So that would be my answer. Basically, make a note off here to the side. It's not that complicated, but if there is an odd exponent, there's always going to be a leftover of that variable underneath the radical. Because that guy's not going to have a pair, he can't come out front. So if the exponent's odd, there's always one left over. All right. So check it out, same concept. You don't want to have to write out B 31 times. So let's use that little 2 trick to kind of help us get my answer started. I could write out the A's, and that'd be really easy for me to see that there's one pair of A's, so one comes out, but there's going to be an A left over, and if it's an odd exponent, there's always a B left over. So think to yourself, how many times does 2 go into 31? Well, I know there's going to be a leftover. 2 goes into 31 15 times. If you absolutely had to use your calculator, you could do 31 divided by 2. 15, but there's always going to be that leftover little guy underneath. So I know there's 15 pairs, so that's how many B's come out. B stays under. That's my final answer. Okay, same deal as last time. Honestly, this just takes practice, and it's kind of the same thing over and over, but like we mentioned in the last lesson, this is like a crucial skill to have to be successful in math classes in high school. So that's my reason that you need to know it. Accept it, please. All right, it's going to just ask me on each problem to simplify. That just means make it look nicer. If things can be pulled out front, that's what you want to do. So remember a little 2 there. Let's do this. I'm not going to write out m. I'm just going to think, how many times does 2 go into 6? It goes in 3. So m to the third will come out front. For the n's, I see that it's an odd exponent, so I know that there's going to be an n left over. If you knock it down 1, since you've accounted for 1 underneath, that'd be n to the 8th, and 2 goes into 8 4 times. So 4 n's will come out front. For the p's, I mean, if you absolutely need to, you can write p. There's 1 pair, 1 left over. That's my answer. Sometimes they will put numbers and variables together. Okay, that just means you combine what we did last time with what we're doing now. So what I would do first is I would take care of the 27 and I would factor tree that. The whole point though is trying to figure out what can come out front. So let's see, I have a pair of 3s, so 3 comes out. And that guy's got to stay underneath. For the exponents, think a little 2 here. 2 goes into 8 4 times with nothing left over. So x to the 4th comes out front. Okay, on the back we got 4 little practice problems. I'm going to have you guys try number 4. I'll do the rest. So number 3 is going to have an idea that we saw in the first lesson where there's already stuff out front to begin with. So if this is me doing this problem, I'm going to bring that stuff down right now. Leave some space because some other stuff is probably going to come out front too. If you don't bring it down right away, there's a really good chance you might forget that it was there. So that's my suggestion. Bring down what's out front right away. Then address and see if anything underneath can come out as well. So let's see. I've got A. And I can write it, or I can think how many times does 2 go into 5? Well, it goes in twice. So a squared comes out. This little a is going to be left underneath though. Then for the b's, 2 goes into 2 once with nothing left over, so bring that guy out. You always want to check to see if you can combine anything out front, and you're going to be multiplying it all. Here's where you got to remember that when you're multiplying like a's or b's, you have to add the exponents. Okay, so here's what my final answer is going to look like here. For the a's, 2 plus 2, that's a to the 4th. For the b's here, add the 1s, so that'd be b squared, and then just a is underneath. So that is my final answer. You guys try number 4, and I'll finish up with 5 and 6. So these are a little complicated looking. They can be a little intimidating, but just like I mentioned last time, if there's 2 radical expressions and they're asking you to multiply them, you always want to make this one problem first. You only want to do factor trees and all that good stuff one time. So make it one problem first. If you try to do factor trees on both and then combine, it's going to be a headache. So get it together. The way you do that is you can multiply the numbers underneath. So 10 times 5 is 50. To bring the g's together, same deal as up here, you add the exponents. So 3 plus 1, g to the 4th. And then add the h's. And guys, you can see like old stuff from this semester, like all the exponent stuff, all the rules. It comes back to get us in this unit. So if you struggle with that stuff, it doesn't mean you're doomed. You just gotta like really practice these skills here. So now I just have one radical that I have to simplify, and I've got numbers and variables. For the number, I'm gonna do a factor tree. And let's see. So 5 would come out, pair of 5s, 2 stays under. For the g's, I've got my little square out here. 2 goes into 4 twice, no leftovers. 2 goes into 9 4 times. So it'd be h to the 4th, but I know that there's a leftover there because it doesn't go in evenly. So that's my answer. All right, last one. This is as crazy as it's going to get in this lesson. Same deal though, I want to make this one problem first, so I only have to do factor trees once. Work carefully here. You can multiply stuff on the outside. So 4 times negative 2 is negative 8. You can multiply the z's, bring them together by adding the exponents, so z to the 4th. Same thing underneath. You can multiply the numbers, so 21 times 3 is 63, and I can add the z's to get z to the 11th. Do not forget to make it one radical first before you do anything else. Okay, now I see I need to simplify this, and I see that there's stuff already up front, so I'm going to bring that down so I don't forget about it. Now I'm going to break down 63. So I can do 9 and 7, 3 and 3, 7 is prime. Okay, so I've got a pair of 3, so I'm going to bring a 3 out. The 7 is going to stay underneath. For the z's, 2 goes into 11. Basically, you knock it down 1. So a z stays under, it's an odd exponent. So think 2 goes into 10 5 times. So there's 5 pairs of z's in z to the 11. Okay, now I look out front, see can I make that any better? Yep, I can multiply the 8 times the 3 to be negative 24. And I can add these z's together, and there's z to the 9th out front. And then radical 7z underneath.